Hey there. Okay, still linear equations, but we're making progress through this section, okay, through this chapter. We're going to talk about ratios and proportions. We have to talk about ratios first because when you set two ratios equal to each other, you get a proportion, and proportions are a special type of linear equation. So today we will learn to translate words into a ratio. We're going to learn to solve both a proportion and an equation using a technique called cross products, which you have seen before. Ready, set, go. Here we go. All right. Definition, a ratio. It's a comparison of two quantities with the same unit. Okay, so if your numerator is in hours, your denominator needs to be made into hours. If your numerator is in miles, then your denominator needs to be converted to miles. Okay, so make sure you're in the same units. And then the way we compare these two quantities is through division. A ratio makes a division equation problem. All right. Remember, if the units are not the same, then you have to convert one of the units. So go ahead and convert to the units of the numerator. All right. Now, in your problem set in the morning when we're together, you could see different ways to read ratio, okay? So I want to make sure you understand that these three separate ways of communicating ratio all mean the same thing. It's the same thing, our little guy. It's the same thing, all right? When you see something A to B, that means you're to write a ratio. This will be your numerator, this will be your denominator. Let me highlight. Numerator, denominator. If you see A colon B, this is your numerator, this is your denominator. Whenever you see A over B, this is a ratio, A to B. A over B, all right? All of these things are different ways to say the exact same thing. It's a TJ Maxx commercial. It's the same thing. I got your picture. I know who's watching. All right, translating words into ratios. First thing you do, place the first number in the numerator. Woohoo! Place the second number in the denominator. Check that the units are exactly the same. If not, convert the denominator. Okay? The ratio of 5 hours to 3 hours. That's going to be 5 over 3. Do we have hours over hours? Yes, we do. So we don't have to convert anything. The ratio of 6 hours to 3 days. That is 6 hours over 3 days. Okay, how many hours in a day? 24. So I have to take 3 times 24, which equals 72 hours. So I get 6 over 72, which equals 1/12. That's the ratio of 1 to 12. 6 hours to 3 days is the ratio 1 hour to 12 hours, right? The ratio of 3 days to 2 weeks, okay? Well, how many days are in a week? 7. So 2 weeks is the equivalent of 14 days, right? So that becomes 3 days over 14 days. 3 is prime and does not go into 14, so that is reduced. So it is 3 days out of 14 days. You try number 4 on your own. It's similar to number 2. Come back, hit the pause button, come back and see if you got it right. All right. I have 12 hours to 4 days. I'm in hours and days, so I'm going to convert 4 days into hours. So I have 4 times 24. That is 96. So I have 12 out of 96. And I believe 12 goes evenly into 96 8 times. So this is 1/8. All right, there we go. So the important thing to remember, if your units are not the same, you must convert. So let's just adopt the idea we'll convert the denominator. Okay, a proportion. A proportion by definition is two ratios that are equal. Okay, so you have two fractions and, wow, and an equal sign. The equal sign is in between them. It's a special kind of equation, and when you have a proportion, it says that the cross products must be equal. The cross products must be equal. Okay? That means when we do a cross product, watch how my pen goes, it's A times D has to equal B times C, just like that. A times D has to equal B times C. All right, be careful that you notice that I have one fraction over here set equal to another fraction over here. I can't have a plus or a minus a non-fraction term with a different denominator. I can't have this and I can't have this. I would have to make this into a common denominator. All right? Let's determine if the following proportions are true or false. What happens? The cross products must be equal. So I have to go 20 times 3. 20 times 3 has to equal 4 times 15. And I get 60 equals 60. This is a true proportion. All right? B, I have to have 6 times 32, and I have to have 7 times 30. So let's do those and see what we get. 6 times 32 is 192, and 7 times 30 is equal to 210. I'm going to write how I got those. This is 6 times 32. This is 7 times 30. This is a false. This one was a true. Okay? It doesn't look much like false, but it is. All right? Our numbers are getting bigger here. Okay, so let's try this one. What do I have to multiply? I have to multiply 21 times 45 and 15 times 62. All right, so we have 21 times 45 equals 15 times 62. 21 times 45, the magic number is 945. 15 times 62, 930. Is that a proportion? No. All right, so this is not a proportion. That when I put that thing in here, it's not, this whole thing is not true. All right, now try D and come back and see what you get. Okay, the first cross product gets me to 1547. This is 13 times 119. And then my second cross product is 17 times 91 and that gives me 1547. So this one is true. True, true, and these two are false. All right. Now we can use this to solve for a missing value of a proportion, and we're going to start off with simpler ones. You've seen these before. Here's what I want you to do in your homework. I want you definitely to write the proportion that they give you down on your paper. Write the proportion down. Then I want to see how you calculated the cross product, and then you're going to solve the equation. It's a linear equation, and you're going to solve. So you are going to write down the original proportion. You are going to calculate the cross products, and you are going to solve for the variable. Here's our first example. 5/9 is equal to x over 3. You're going to write down the problem, just like I did here. Then you're going to calculate the cross products, and then you're going to solve for x. So I have 315 is equal to 9x. Then I'm going to divide by 9, and I get x is equal to 35. The other way of asking yourself to check it is to say, what do I have to multiply 9 by to get 63? Ooh, 7. So that means I got to multiply 5 by 7. All right, and that gives us 35. You guys try this one, hit the pause button, and come back and check to see if you got it right. Don't forget to do all 3 steps. Write the problem, calculate the cross products, solve the variable. Even though the problem's written right here, I know that. I know that. All right, welcome back. My first step is to write the problem down. X over 6 is equal to 35 over 42. Step 2 says do the cross product. 42x is equal to 35 times 6. That's 30. That's 210. All right, and now I have to divide by 42. I know it's divisible by 2. Oh, it goes in evenly. So x is equal to 5. Okay, another way to check this is, what do I have to multiply 6 by to get 42? Oh, that's times 7. All right, so that means I have to multiply something by 7 to get 35, or I have to divide 35 by 7, and that gives us 5. Okay, was that the same problem? Nope, just similar answer. There we go. Okay, here we go. Oh, I got your picture again. Ooh! All right, he's giving us a message here. Let's see. We're going to use cross products. Notice that I have one fraction set equal to another fraction. Notice how this is not the same as x over 5 minus 2 is equal to x over 3 plus 1. Okay? I can't do cross products on this, but I can do cross products on these. Here's what I want you to do. Anytime you have more of a, I kind of refer to it as a compound numerator, it has more than one term, all right? I'm going to put parentheses around it because that's going to remind me to distribute. So the only thing we've really added in this is, do I need to distribute? All right? So he reminds us to use our parentheses. Step 1, write that problem. Even though I have very limited space, I'm going to write that problem. And I'm going to put parentheses around my multi-term numerator. Then I'm going to do my cross product. 3 times x minus 2 has to equal 5 times x plus 1. So I get 3x minus 6 equals 5x plus 5. All right? I'm going to subtract 5 and I get 3x minus 11 equals 5x. I'm going to subtract 3x and I get negative 11 is equal to 2x. So x equals, always in my way, negative 11 halves, or negative 5.5. All right, let's just double check because that's a weird number. 5x plus 5 is 11. Yes, that is correct. All right, if we plug that in and simplify, we will get the same answer on both sides. I'm taking your picture all day long. You try this one. Remember, what does he tell us to do when we have multi-term numerator? Boom. Put parentheses around it. You solve this one. Put it on pause. Solve it. Come back. Write the problem. Did you write the problem? Write the problem. All right. Here we go. 1. I'm writing the problem. Over 2 equals 2 fifths. All right? Put parentheses around here. So I'm going to cross product 5 times x plus 6 has to equal 4. So I have 5x plus 30 has to equal 4. 5x has to equal negative 26. X has to equal negative 26 over 5. All right? There we go. There's our homework. Woo, this was a fast lesson. All right? These are the problems that we're going to do tomorrow in class. Come prepared. All right, I'll see you. Thanks for watching. Have a great evening. It's a pleasure being your teacher. Bye.